Hi everyone, I'm Michele, founder of the Harmonic Laboratories and also creator and currently only maintainer of Plutias. And in this video, I'd love to give you a quick introduction to Plutias and what is possible to do with it. And in order to do that, we'll use the Plutias documentation that if you want, you can find at plutias.harmoniclabs.tech. And here we are in the introduction page of Plutias, where we have a quick description of what Plutias is meant to be, which is a library for building Cardano decentralized application in an efficient and developer-friendly way. And it is mainly composed by two parts. There is the on-chain part, which is the more known one, because it allows you to write and compile smart contract only using Typescript, and that means that it works both in a server environment and in a browser environment. And there is also the off-chain part, which is less known but equally powerful, which allows you to create transaction only using Typescript, and currently is the only option that allows you to do that without any WebAssembly running, which may impact your application performances. And this is so important that even Mesh is updating the dependency from the Cardano serialization library, which relies on WebAssembly, to Plutias off-chain, so that you will be able to get more efficient application with a better user experience. Anyway, we'll see both these two parts in action, and in order to do that, we'll follow the Hello Plutias example that we have here in the documentation. And I already have a completed version of the project, so we are going to use that. But if you want to go through this example before I spoil you anything, maybe you should pause the video and go check out this page. So with that, we can get started. Of course, this project uses Plutias, and it also uses a Mesh SDK so that we can have a user interface to interact with the contract. And if you want, there is also a live demo of what the final project should look like. And here there are also the instructions to get started with this project. As I said, I already have it completed here, and we are going to base ourselves upon this completed version. And if we go back here on the documentation, we can see the project structure that we have. We have most of the code basically on the SRC folder, but there is also the contracts folder where we can find our contract, and then the SRC is used to describe the user interface here and the off-chain logic here. So we can see the same structure in this project, of course, and maybe we'll start from the user interface and how it is structured. Of course, there will be an entire video from the Mesh team explaining the user interface, since I'm not that good at user interface. But from here, we can see how the page is structured. There is a connection handler for the wallet, and then when the wallet is connected, it also displays a couple of buttons, as we see a moment ago on the live demo. And these buttons are doing two different things. When we click the first, it calls the unlock function, and when it calls the second, it calls the unlock function. These functions are defined right here, and what they are doing is calling these two asynchronous functions that are creating a transaction. And if the promise resolves correctly, then we show to the user that the transaction was submitted successfully. Otherwise, we notify the user that something went wrong. So the real difference between these two functions are the transaction that is being created and that is happening in the off-chain logic. So in order to understand why we are creating these two transactions, is probably a good idea to go have a look at the contract and what is running. So this is a basic structure of a Plutias contract and how it is organized. A contract, as you know, is just a function that takes a datum, a redeemer, and the script context. And then based on these three inputs, it should return a boolean to validate the spending of an UTX. So this is of course the case for a spending validator. Then here is where the compilation is happening. As you already know, every validator has to be untyped. So this is the role of make validator here. We are passing our type contract. In fact, despite, well, of course, running in JavaScript, which is not very well known for having a type safe type system, Plutias instead does implement its own type system so that everything is strongly typed. And as an example, if I change the type of this right here, then now message is an integer, and we see that we get an error because this is not expected. And I'll say you more, if you try to run this code, while TypeScript will as an error, but JavaScript won't. However, this is type checked, so the compilation of this contract will fail. So you will never get, unless you are really, really trying hard, uh, you will never get something that isn't working as you intend based on the type. So changing the type back to a byte string, which is what is meant to be, we see that the error is gone. And once we have our untyped validator, we can call the compile function on the untyped validator. This will transform our contract into a new int 8 array, so in row bytes. And these row bytes can be passed to a script object, which is part of the off-chain side of Plutias, to create a script which will give us utility functions such as script to cbor or to JSON, which of course are not present on our row byte object. So as I said a moment ago, we are here to have a look at the logic of the contract, and we see that the contract takes as datum a pub key hash representing an owner of a given UTXO. As we know, datums are attached to specific UTXOs, so each UTXO does keep track of the owner, then a message that is passed when calling the contract, and then of course takes the script context, which gives us more information about the transactions in which the script is included and the purpose of the script. So based on these three inputs, we are checking a couple of things. We are checking that the message, so the redeemer that is passed by the user, is strictly equal to the hello Plutias message. This is then casted to a byte string, and this is done by calling the echo method for equality on a byte string object. And then the second condition is that the transaction is signed by the owner. We have access to the transaction through the context, and we can use dot notation to access the field. So we have context.transaction.signatories, which is a field of the transaction object. And then this signatories is a list of, well, aliases of byte string, which are basically pub key hashes. So we have a list of public key hashes, and we can use the sum method to check for each signatories that at least one is equal to the owner we keep track in the datum. So if this condition is true, that means that the owner has signed the transaction we are validating. And so if the message is equal to hello Plutias and the transaction is signed by the owner, then we say that for us it's okay to spend the UTXO. So this is the validation logic of our contract. And now that we know what the contract is doing, we can take a look at the lock transaction, which is founding the contract, so it's creating an UTXO that the contract can later validate, and then also the unlock, which is where the contract will run. So first of all, we'll go check the lock transaction. And the lock transaction, which if you remember is the function that is called on lock here, is of course an asynchronous function, which is calling getLock transaction, which is our function up here. Then it is using the wallet passed from mesh. Here we can see that this wallet comes from the use wallet that we are importing from mesh SDK. So we are signing the transaction with the wallet of the user, and then we are using Koios to submit the transaction to the blockchain. So let's see how we create the transaction. So based on the wallet, we can get one of the addresses using wallet get change address. This is all present in the mesh documentation. Then we are constructing a transaction builder, and if you go look how get transaction builder is working, it is performing an asynchronous request to Koios to fetch the protocol parameters which are needed to check that the transaction is correct according to the protocol parameter of the blockchain. So using those protocol parameters, we can construct a transaction builder. The main method that exposes is the build sync, and it takes a lot of inputs, which are often optional, as in our case. So here we are trying to construct a transaction builder. It might happen that the protocol parameter are missing some field somewhere. If that is the case, then the transaction builder will throw an error because it's missing some fields necessary to construct a transaction. In that case, we may want to use the default protocol parameters exported by Plutias, but you should be careful with this because these ones might not reflect the reality of the protocol parameters. So this should really be only used as a fallback. Anyway, going back to the lock transaction, we now have our transaction builder. And from the wallet, which is our user, we can get UTXOs, and these UTXOs are in the mesh format. The transaction builder will not like the mesh format of the UTXOs, so we are just using a utility function that will get a mesh UTXO and will transform it in a Plutias UTXO. This is really nothing to worry about. And once we have all the UTXOs of the user, we only want really one UTXO that has at least 15 ADA, and using that UTXO we can finally build our transaction. So as I said before, we're using the transaction builder and calling the build sync function, and we are passing as input the UTXO we extracted. Here, the important part of this transaction is this one. We are creating an output to the script testnet address. Now this script testnet address is the one we are exporting from contracts, and it is basically the compiled script, and then we build an address using the script as payment credential. So using this address, we can specify it to be the address of the output. We are sending to the script 10 of the 15 ADA we have from the input, and we are making sure that we are keeping track of our payment credential hash, so our public key hash, in the inline datum of the UTXO. So now if we go back on the contract, this owner will be set to be the user payment credential, and then we are specifying that everything that is left from the inputs should be sent back to the address of the user. So if we now run locally this code so that we are sure that this is what is running, we can do that by running npm run dev. Since this is a Next.js project, we get sent to this localhost 3000 URL. Here the page is constructing. As you can see, this is all the WebAssembly that Mesh SDK is based on, but fortunately for us, Mesh SDK is updating in version 2 to Plutias, so that all this loading time will not be needed at all. Going back to the local web app, we can connect our wallet just like the live demo. And if you remember, we need to click the first button in order to call what was our lock transaction function. So remember, what is going on is this one. So we are constructing the transaction, then we'll be prompted to sign the transaction, and then we will submit it. Let's see if it works. We click here, and indeed we get our Nami wallet prompted to be signed. So let me sign this transaction. And as you can see, the transaction was successfully submitted. Eventually we can go check for this transaction. If you get this screen, don't worry, it takes a couple of seconds for the transaction to be included in the chain. And as we can see, after a couple of seconds, this transaction is showing on the Cardano Scan website. The next step is the unlocking transaction, and we have defined the unlocking transaction here. The structure is very similar. We are signing and submitting this transaction here. What changes is how we get the transaction. So the first thing we are doing in this function is getting all the addresses that the wallet does have. We are once again getting the transaction builder, and once again we are getting the UTXOs as we did before. So here there is nothing new. What is new instead is that we can't use something like wallet get UTXOs on the script, so we will use Koios to fetch the UTXOs that are present on the script address. This will return an UTXO array just like wallet get UTXOs, and over those UTXOs we only want to keep the first that satisfies this predicate. So what we are searching for is an UTXO that has a datum that is in line as we set it in the previous transaction, and that the format of the datum is just composed as row bytes. If that is the case, then we extract the value of the datum, and we are comparing the public key hash that is present on the UTXO against any of the public key hashes of all the addresses of the user. So if any of that is actually the one on the datum, that means that we can spend that UTXO, and so we set the address at that index to be the address to be used, and we return true, meaning that we found the UTXO we're searching for. Otherwise, if none of the public key hash governed by the user is the one that the UTXO is keeping track of, then this will return -1, and in that case will return false. If the datum is not even in line, then we directly return false. So at this point, UTXO to spend we know is of the correct form. So using what we have, we can use the UTXO to spend that we know it comes from the script. So if the UTXO is coming from the script, we have to include the script in the transaction so that the script can validate the spending of the UTXO. So in this transaction is where the script is running. So we are including the script here. We know that the datum is already present on the UTXO we are spending, so we are telling that to the transaction builder by passing the datum to be the literal string in line, and then we are passing the redeemer to be the hello Plutias message, because that is what the contract is expecting. The contract is also expecting the transaction signatories to include the pub key hash of the owner that has to be specified in the required signature. Otherwise, the transaction signatories will be empty. And then, since we have a script in our transaction, we also have to be sure to include a collateral. And just like before, then we are telling to send everything back to the user address. So this is our transaction, and we can try to run this code by clicking the second button, this time of our local application. We see that we are prompted to sign the transaction, and actually, since everything is deterministic, we already know that the transaction is being built correctly and the script is succeeding. That is because the Plutias transaction builder is already evaluating the script, which is not something that every transaction creation library is doing. Fortunately for us, Plutias is of course able to do that. So it is evaluating the script and checking that everything is okay. And I can show you that because if I here change the message, then the contract will not be happy with the different message. So if we now go here, we reconnect the wallet because it refreshed the page because the code has changed. And now we click the unlock transaction. It will not prompt us because the script failed. And in fact, it gives us here an error. That is because the Plutias transaction builder had a look at the script and it saw that the message is not correct. So the contract was unhappy and it returned false here. And since it returned false, we have not the input for our transaction. So this is really good to avoid sending invalid transaction and potentially losing the collateral. If we build the correct transaction and we are prompted to sign the transaction, we are already pretty much sure that everything is good here. And in this transaction, we are receiving the 10 ADA minus the fee of the smart contract execution, so 9 ADA plus something. We can sign this transaction, and once again we see that the transaction has been submitted correctly. We can go check what is going on there, and here we have it. We see that the transaction includes a contract, which is our contract, and we can see the compiled contract right here, and we see that the transaction does also include the datum, which is our public key hash. So we can definitely tell that the transaction went through correctly, and this is how you would build a web application using Plutias. But before ending this video, I want also to show you how you would transform this very simple contract to something like a vesting contract, since it is really not that different. Why I want to show that? Well, because it requires a couple of concepts of Plutias more, which in my opinion, are pretty cool. So the first concept is the concept of a struct. In fact, the datum not only needs to keep track of the owner, but we'll also need to keep track of the deadline. We need two fields for the datum, so we need a structure. In order to define a structure, we can use this construct in Plutias. So we declare a variable using const. Then the name of our struct type will be vesting datum, and we can define a Plutias type using the pstruct. And the pstruct takes an object which has as keys the names of the constructor. It's fine just to call the constructor just like the struct. And here we are passing what are the name of the fields of the struct. Namely, we want the owner, as we already have, to be the pub key hash of the owner. And we also want to keep track of the deadline of the vesting we are creating. So we'll introduce a deadline field, which is of type integer. So as you can see, this is how you would define a structure type in Plutias. And now this is a valid type, so we can just take this and access the type static method to get the Plutias type, so that the type checker will be able to check that we have indeed a vesting datum here. And now this is no longer the owner, but it is the vesting. And well, we can access the owner doing vesting.owner, since this is a field, and we see that this is a byte string just like before, but we can also use JavaScript destructuring here if we are more comfortable with that. We just extract here the owner and the deadline to have directly the values. So now the signed by owner is correct once again, but we also have access to the deadline. And how do we check the deadline to be fast? Well, we have access, as you know, of the interval in which the transaction is considered valid. So we'll just change this is being polite to deadline reached, and we'll first get the transaction interval of the validity of the transaction. So we can do that by starting from the script context. So context, then access the transaction, then accessing the interval, and then from the interval we have access to the from and to fields. We want the from because we are searching for the lower bound of the transaction, and we have access to the bound. Now, if you get lost in this process, don't worry, because there is the documentation for that. And in particular, you can go on the on-chain, and then what we're using is the API. And here we'll have all the on-chain types that are already present. As said before, we started from the context, then we accessed the transaction field, then we accessed the interval field, which is down here, and the interval field is of POSIX time range type. Now, the POSIX time range is just an interval. As we saw, it has a from and a to field. Then both those two have a bound and an inclusive field, and what we access it is the bound. The bound is an extended, and all these types are structs. Now, what we notice is that all these structs up to here are formed with a single constructor, so that is why we were able to use straight dot notation here. However, in the case of multiple constructors such as p-extended, we cannot directly access the fields because we don't know which fields are there. So in this case, what we want to use is pmatch construct that you can find the documentation under control flow, and pmatch is giving us all the possible constructor that were used for that particular struct. If you go back, you can see indeed that there were string constructor for the bound field, and here indeed we have access to three constructor plus an underscore wildcard. What we want to do is only to access to the pfinite constructor because it's the only one that has an actual deadline, and well, we'll use this in a moment. And we also want to specify that any other constructor, so in this case negative infinite and positive infinite, we can use the underscore wildcard to match all of them. And we want to say that for any of them we just want to return false because we are assuming that the deadline is not reached. Now, to check that the deadline is reached, we can once again use the object destructuring to gain access to the underscore zero field in this case, and we can do that by using some parentheses, curly brackets, and then accessing the field. And we can also conveniently rename it to lower bound. And to check that the lower bound is passed, we are checking that the lower bound of the transaction is lower than or equal to the deadline we keep track in our datum. Whoops, is actually the contrary. We want the deadline to be lower than the lower interval. All right. So if the deadline is lower than the lower bound, that means that it is in a point in time before the minimum time the transaction can ever be sent. So we are sure that the deadline isn't as indeed passed. And so this is how you would describe a potential vesting validator. Of course, we are not going to integrate this in the UI since it will take some work, and we do not really have that much time in this video. But if you want, you can have fun updating the project so that it works with this new contract. Anyway, I hope you got an idea of what is possible to do using Plutias. If you want to use it and you're finding some issue, feel free to open an issue on the GitHub that you find up here in the documentation, or even feel free to join the Discord that you can find on the very bottom here. You'll find a link to the Harmonic Laboratories Discord. There are lots of people there that are using Plutias, and you'll find myself too. And if you ever struggle with anything, I'll be more than happy to answer any of your questions. So just jump on the Discord if you want. So that was everything for this video. Thank you for your attention.